You are welcome back. So here we will discuss the alkenes, the next homologous series after the alkane family. So the alkane family, they are hydrocarbons just like the alkanes, and also they have the general molecular formula of CnH2n. We saw that in the past. And remember their functional groups. The functional group of alkenes is carbon to carbon double bond. Let's look at the first three members of the alkene family. Ethene, we've been talking about ethene today. Propane, the next family, and butane. For butane, the molecular formula is C2H4, and this guy is C3H6, and this is going to be C4H8. Let's have the displayed formula for ethene, carbon to carbon double bond, the functional group. And then we have 4 hydrogen atoms to attach to the carbon atoms. For propane, 3 carbon atoms, 1, 2, 3. And then you know it is 6 hydrogen atoms, right? So it means 1, 2, 3, 4, 5, 6, 7, 8. So something is wrong. So you know what is wrong because there's no carbon to carbon double bond. So let us include that to make this compound an alkene family. So when I introduce carbon to carbon double bond, definitely I have to remove some of the hydrogen atoms. And so this hydrogen atom will go. So we have 4 bonds around these carbon atoms. 1, 2, 3, 4. And this one, how many carbon atoms? How many bonds around this carbon? We have 5, so we need to remove 1 more hydrogen atoms. So this is propane. If you count the bonds around the hydrogen atom, it will be 1, 2, 3, 4. So this is fine. For the second carbon, 1, 2, 3, 4. This is also fine. So the third carbon atom, 1, 2, 3, 4. This is fine. In fact, you can check the hydrogen at the 6. 1, 2, 3, 4, 5, 6. So we are correct. What about but 1 in? Let's supply the carbon first. So these are the 4 carbon atoms. I have to number this. But before we number, let's just put, let's supply hydrogen atoms first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will agree that this is not the same as this molecular formula C4H8. This is the formula for the alkane counterpart, which is butane. But we are talking about but1ene. So we need to remove some hydrogen atom. We need to introduce our double bond. Now, where do we put the double bond? Let us count the carbon atoms. 1, 2, 3, 4. We give the carbon atom, we give it the number. So the carbon that is carrying number 1 will be the one that will carry our double bond. The double bond, that is the carbon to carbon double bond, is called ene. And that ene, our ene in this compound, is attached to carbon number 1. So that is why our double bond will be between carbon 1 and carbon 2. When our double bond is between carbon number 1 and carbon number 2, we need to reduce the number of hydrogen atoms in those carbon atoms. So in order to have 4 bonds around the carbon, so there is 4 bonds around this, and then you can remove this one down here, no problem. So we have 4 bonds around this carbon atom as well. So in that regard, we have our butene. If you count the carbon, 4, count the hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8. So we are correct. But1ene means but 4 carbon atoms in the functional group. That ene is attached to carbon number 1, and you can see it here. And if you look at the boiling point, let's compare the physical properties of 4 of them. Definitely the guy that has the shortest chain will have the lowest boiling point. The boiling point of ethane is minus 102 degrees centigrade. For propane, it is minus 47. It is increasing now. And for butane, it is what? Minus 6.5 degrees centigrade. This one has the highest boiling point because it has the longest chain. Don't forget. Let's look at the reactions of the alkenes. So we are going to take one of the family members to demonstrate the reactions. C2H4 to represent all the family members. Before we look at their reaction, remember that we make ethane. So I will remove this. I will call it making ethane. Can you remember how ethane is made? Ethane is made by cracking ethane. We saw that today. C2H6. When we subject it to cracking in the presence of what? Steam. Don't forget this. And then the temperature greater than 800 degrees centigrade. And we are going to get our ethane C4, C2H4, and another important product, which is a hydrogen gas. So that is how to make ethane. Now let's look at reactions of ethane. So we're using ethane because it will represent other homologous series. Remember we said they have similar chemical properties. So it means the reaction of ethane will be similar to how other will react as well. So let's look at the reactions. The first one is reaction with hydrogen. So I can call it hydrogenation, but it is not mentioned in IGCSE. I will just say reaction with hydrogen. Or if you want, it is also called hydrogenation. So this reaction is ethane C2H what? C2H4. We're talking about reaction of ethane with hydrogen this time around. Let's use the displayed formula so it will be easier to understand. Carbon to carbon double bond, H and H, H and this H, which is what? C2H4. So when this one undergo reaction with hydrogen, remember this is a gas, it's a gas. So react with hydrogen, which is also a gas, and then we can get what? We are going to get a very important product, which is, let me write this hydrogen this way. H2 means H bond to H. So what we are trying to do is that we are adding hydrogen to this ethane. If you have C2H4, you add H2 to it. What are you going to get? You're going to get C2H6. Exactly. So you just adding hydrogen to ethane. So we are going to get C double bond. I will put this double bond, then H, 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 and H. So when we add these two new hydrogen on this, it's going to be one we add here and the other one we add here. They will add across the double bond. And by doing that, double bond will become a single bond like this. So if you check, we have, what do you call it? We have our ethane from our ethene. Ethene becomes what? It becomes ethane by adding hydrogen to it. And that is why this reaction is called what? It is called addition reaction. There's something I'm leaving out too, which I must not leave out. That is the presence of catalyst. This reaction will never happen if there is no catalyst involved. So what is the catalyst used in this reaction? The catalyst is nickel. So we use nickel catalyst in this reaction. IGCSE wants you to mention the temperature and then the and the pressure as well. So they don't need the exact value for that temperature. You just say heat is involved and also pressure is involved in the reaction. Heat, pressure, and nickel catalyst are used to achieve this reaction. So, and the name of this reaction is what? Addition reaction. It is addition reaction because what? Only one product is formed. If you remember, we said the alkanes are saturated. If you remember, we said they are saturated hydrocarbons because they have carbon to carbon single bonds only. But for alkenes, they are not saturated. So we call them unsaturated hydrocarbons. Why are they unsaturated hydrocarbons? Because they have carbon to carbon double bonds. Now, if you want to define addition reaction, you will say a reaction that turns an unsaturated hydrocarbon into a saturated compound. You can also add this that there is only one product formed. Let me give you an example of addition reaction. So the first one here is addition of hydrogen. So the next one that we want to look at here is addition of steam. So steam means water in vapor form, that is water in gaseous form. So steam, this is our ethene. We are still using ethene. So ethene can undergo addition reaction. Ethene is what? C2H4 can be reacted with water. So with this H2O, I will write this water this way, HOH. So you will understand how the product is formed. So we are going to get, I will write C double bond H C, and then we have this H. That is our ethene. Now we are adding the H and OH across the double bond, the way we did in the case of addition of hydrogen here. The first hydrogen atom comes to the carbon at the right, and then the other one comes to the carbon at the left side. So, in fact, I will make this one propane. So let's make this one propane. So you know what is when you know where the hydrogen, where we add the hydrogen. So let's make this one propane. So I think we are fine with that. We'll change the molecular formula as well. So this is hydrogen atom. This is carbon with 3 hydrogen atoms around it. So this is going to be C3H6, C3H6, and then we have our water. So I still have my C3H6 here. Now I want to add this water. I said the water will be added across the double bond. So you look at the two carbons that are carrying the double bond, because it is double bond that make this compound saturated, that make it unsaturated, this compound. It is double bond. So we want to turn it from an unsaturated compound to a saturated compound. So it means we are going to break the double bond. So the incoming reagent here, that is this water, is coming to break the double bond. To break the double bond, it means one of this, the OH will go to one of the carbon, and then the H will come to the other carbon atom, something like this. So we have our OH at this side, and then we have our hydrogen at this side, and then the double bond will go. It becomes what? It becomes a single bond, something like this. So something like this will happen. If I want to use higher organic chemistry method, I think it's supposed to be like this. Let me put the double bond. We call something Markovnikov rule. You don't need to disturb yourself with that. So the hydrogen, this H, it doesn't matter anyway at this level. This H will come to this hydrogen atom here, the guy that has two hydrogen atoms. So it will prefer to react with that, and then it could come, the OH will come to the carbon that has less hydrogen atoms, something like this. So we have OH, and then we have this one bond to the H. Remember, I said displayed formula. So let me put a bond between the H and the O like this. So we are fine this way. So in this regard, we have formed what? You will see that we form uh, al alkanol from the alkane. So addition of water to your alkene will give you alcohol. C3H6 plus water give us C what? C3H7 OH. If you count, it's going to be H7. 1, 2, 3. Three carbon atoms. 1, 2, 3, 4, 5, 6, 7. H7, and then our OH, then OH. So everything. Yeah, so we have our propane. When it undergoes additional reaction with steam, it becomes what? Propan 2 oil. Our OH, which is the oil, is attached to which carbon? Carbon number 2. 1, 2. Okay, so that is addition of steam to alkene. It will give you alcohol. So this reaction also happens in the presence of catalyst. The condition of the reaction apart from catalyst is heat, pressure, and then a special form of catalyst which is called an acid catalyst. The third example that I will give of addition reaction, we are going to use it to test for unsaturation. So we're going to